So as I was saying, this week we're going to see all about factoring polynomials, different techniques depending on the type of polynomials that we have to factor. Last week we worked out some operations with polynomials, and some of these operations has to do with the rules of exponents that we saw before that. We're going to see how to use the GCF, greatest common factor, to factor a polynomial. Also, we're going to see how to somehow, related to the GCF, we're going to factor by grouping as well. All right, so we have to group and apply the GCF for each of the groups we have in order to factor the polynomial. So let's start with what the GCF is. The greatest common factors. White color is good. So GCF, greatest common factor. Let me remind you what a factorization is. So for example, I have the number 35. So what I want is to break apart the number 35 using like prime numbers. So 35, for example, is 5 times 7. Right? So 5 times 7 is 35. So 1 is the multiplication. So doing the multiplication, you get the result, which is the product, number 35. And if I give you the number 35 and say, hey, factor, it means breaking into the factors that when you multiply them, it gives you that number. And that is the factoring part of the number, right? So think of factoring as like a reverse of multiplication. So you are trying to factor things, breaking into factors. So those factors, when they multiply, is give you back what you had originally. And it's always easy to check if your factor is correct, because all you need to do is to multiply the numbers. For us, we now want to do that for polynomials. So for polynomials, right? So we can use what's called the GCF. It's not the only technique, but we always try to look at that first because it makes things easier for factoring. All right, so let me give an example for polynomials. So I have a polynomial 3x plus 6, right? So we saw that this is a binomial because it has two terms. And I want to factor this polynomial. So the way I factor is by looking what's common between the two terms. So there are two terms. Both terms can be divided by the number 3. So it's the number 3 times something, okay? And you can see that factor number 1, term number 1 is 3 times x. So it's already kind of in the factorization form. And term number 2, you have 6, which is 3 times 2. So both of them are divisible by 3. So this is the common factor, and it is the greatest common factor because there is nothing bigger than 3 that will divide both of the terms. So it's 3 times something, right? So I know 3 is a factor, so I can factor out. Now, the way I figured out the rest, the other factor is, okay, look at the first term. The first term is, what is my point there? I found it. So the first term, if you know that 3 is your factor, the greatest common factor, you take that and divide it by 3. So if you divide that by 3, the result is x. So x go into the second factor, okay? Now, the second factor for the second term, second term, which is 3 times 2, and you know 3 is your factor. So if you divide that by 3, you get 2. So positive 2 is the other part of that factor. If you take 3 times x plus 2, you apply distributive law. The result is 3x plus 6. And you can see it's exactly what I had originally. So the factorization is 3 times x plus 2. So remember, 3 is a polynomial. It's a polynomial with one term, a monomial. And x plus 2 is another polynomial, which is a binomial, actually, right? So that is the factorization of polynomial. So you're going to see that, okay, in this case, it's kind of, in your face type of factorization, but it's not always like that. So you really have to think how to retrieve from the GCF the factorization itself. Obviously, we don't have to write all this, right? So you get the GCF and then you break apart the terms using the GCF, okay? All right. So let me give you another examples here, and then we're going to move on back to the handout to do those examples. So more example. Let's just find the GCF of the following. I'm not asking to factor, I'm just saying let's find what is the GCF. So since numbers, they are monomials with one term only, which is the coefficient, let's start with that. So we're going to find the GCF between 14 and 24. Part B, let's find the GCF of some powers of fact. 6a squared and 5a to the 7th. So there is 4 different monomials. I want to find the GCF of them. Okay. Let us see. Let's find the GCF between 10x to the 5th and 35x to the 4th. Okay. Now, I put the different kind of things that you should be looking every time you're trying to find the GCF. It depends on the terms. So terms are numbers times powers of variables. So I put the numbers there, so we're going to find the GCF for them. Powers of variable, also part of the polynomials, each term. And then, of course, it's a multiplication of both, so that's what we see also in part C. Okay, so I wanted the GCF for letter A, which is the number 14 and 24. So since they are only numbers, you look for the number that divide both. And if you have more than one number that divide both, of course, you're looking for the greatest number. The GCF, greatest common factor, means the largest number that divide the coefficients, in this case, the numbers. Now, the numbers that divide 14, so let me put it here, is just what I'm thinking. You don't have to write this, but you have to think about this. So numbers that divide, okay, first let's check 14. So the numbers that divide 14, well, 1 divided 14, right? Because 14 divided by 1 is 14. 2 divides 14 because 14 divided by 2 is 7. Of course, 7 divides 14. The result is 2. And 14 itself also divides 14, right? 14 divided by 14 is 1. So these are all the factors we can use to divide 14. Now, for the number 24, okay, of course, 1 always divide any kind of number. So we always look at that. Usually it's not the GCF because it has to be the greatest, right? So unless they don't have anything in common, 1 is not going to be part of GCF. So 1 divides 24, 2 divides 24, 6 divides, 4, hold on, let me erase this. 4 divides 24, 6 divide 24, 12 divide 24, and I believe then the next one has to be 24. Okay, so all these numbers divide 24. Now I'm looking for the common factor, so and the largest of both. So if you look at that, the only thing this list of factors they have in common is the number 2. So 2 is a common factor of both, and not just 2, but 1 as well, right? But again, I'm looking for the greatest common factor, so 2 is the GCF. So the GCF is 2 because of that. Okay? Any questions about this? Now, for part B, when you have a variable, you're looking for divisors of that power with the variable. So it has to be common for all the terms. So here we have 4 terms, right? So a to the 5th, a to the 6th, a squared, 5a to the 7th. So there are 4 terms. So what these terms have in common, as you can see, they all have a as a factor, right? So let me put here, for example, a to the 5th. A is a factor because it's a times a to the 4th. You can write a times a to the 3rd, and so on. So there are many different ways you can write this. But a is a factor. Now, it could be a higher power of the factor, and so on. Okay, so any kind of power involving a with an exponent up to 5 divides a to the 5th. And a to the 6th is the same thing, a squared is the same thing, 5a to the 7 is the same thing. I didn't want to include the number, but since I already did, I just wanted you to think about the powers of a so far. Since it has to divide all of them, the one with the lowest exponent is the common factor, because of course a higher exponent does not divide into the smaller exponent. Okay, so for example, a to the 5th cannot be divided by a to the 7th. As a polynomial, the exponent has to be always a whole number, and we know by properties of exponent that this is 5 minus 7, the exponent, so it's a minus 2. Negative 2 is not a permissible exponent for when you have powers in a polynomial. We're talking about polynomials. So this is not a polynomial. So that's why we're not considering the large numbers in the exponent. We actually look for the smallest. So among all these powers you see for letter B, a squared is the one that divides all of them. Okay, so here is the division. So for example, a to the 5th can be divided by a squared. The result is a to the 3rd because it's 5 minus 2, 3. And then a to the 6th can be divided by a squared. The result is a to the 4th. A squared can be divided by a squared. The result is a to the 0, which is just 1. And 5a to the 7th can be divided by a squared. The result is 5a to the 5th. Okay, so they all can be divided by a squared. So the idea is that, okay, besides of the power, so now I know I have GCF with the power a squared, I need to look at the coefficients. The coefficients of almost all of them is 1, except the last one, which has a coefficient 5. So I'm talking about these guys right here. So you can see this is an invisible 1 times a to the 5th, invisible 1 times a to the 6th, invisible 1 times a squared. And this is not invisible, it's really 5, right? Among the numbers, the GCF is 1, because 1 can divide all of them. So 1 a squared, or just a squared, is the GCF of these 4 terms. Okay. So for numbers, we look at the biggest number that divide all of them. If it does not divide one of them, so it cannot be a common factor, so it's not the GCF. So the GCF is composed of the number that divides all the coefficients and has to be the largest one. And for when there is a common variable everywhere for all the terms, then the smallest exponent is what I'm looking for. All right, so here for letter 6 is a mixture, right? So it's numbers and powers, and I'm looking for the GCF. So first the number, so looking for the GCF. So first I look at the numbers. So the numbers in the two of them is 10 and 35. What is common, meaning can be divided by the number, whatever is common factor, we have that 1 divides all of them, 5 divides all of them. But between 1 and 5, 5 is what I'm looking for. So 5 is the common factor I'm looking for just for the numbers. Now for the variables, I have x to the 5th and x to the 4th. What is common as a power, common factor, is the power x to the 4th. Okay, because x to the 4th divides x to the 5th. The result is just x. X to the 4th divides also x to the 4th. So x to the 4th divides x to the 4th. So the result is 1. So it's a polynomial. So my GCF is the 5 common factor of the coefficients, and x to the 4th the common factor of the variable x, the powers with the variable x. Okay, so 5x to the 4th divides 10x to the 5th and divides also 35x to the 4th. Okay, so that's why it's a GCF for that. The next thing I want to mention, now that we know what the GCF is, how we use that to factor. An example, use the GCF to factor. What we're going to try to factor, let's start with 5x plus 20. Part B, 8x squared plus 12x. Okay, GCF is the greatest common factor. So you look at the numbers first, see which one divides all the numbers, right? And it has to, if you have more than one number that does that, so you have to pick the largest number that does that. For the powers of the variable, you have to look for the power with the smallest exponent you see among all the powers. Letter A that you see there, we want to first find the GCF. Once we know that, we're going to use to factor. So let's start with find what the GCF is. So the GCF for the polynomial 5x plus 20, so it has two terms, right? So look at the two terms. There are coefficients in each of the terms, right? So the first coefficient is 5, the second is 20. So the number that divides 5 and 20. So number 1 divides 5 and 20. 5 divides 5 and 20. But no other number divides at the same time 5 and 20. There are numbers that divide just 20 and numbers that divide just 5. But together, 1 and 5 are the factors. So factors of the coefficients, just the numbers of the polynomial. I needed the largest among them, and that is 5. So part of the GCF is to use 5. And now I'm going to look at the power for the variable. If the variable does not show in all the terms, it's not common. Therefore, it should not be part of GCF. So we have the variable x for the first term, x for the first term, and then 20 does not have x. So x is not a common factor. It's just a factor of the first term. So my GCF is just the number 5 because the variable x is not common. My 5x plus 20 can be written as 5 times. Inside that parenthesis, I expect to have a two-term polynomial because the original polynomial, 5x plus 20, has two terms. So if these two terms are divided by 5, right? So for the first term, if you divide that by 5, you get just x. For the second term, if you divide that by 5, your GCF, you get 4, right? So inside the parentheses, when I divide it by 5, the result goes inside the parentheses. So I have 5 times inside the parentheses, you have x, and then plus 4. So the answer for part A is the factorization I just gave, which is 5 times x plus 4. And again, you can check to see that this is correct by just multiplying. So if you distribute 5 into the binomial x plus 4, when you do that multiplication, the result is my original polynomial 5x plus 20. Let me do like this. So part B, I'll write on the right side of the screen. So for part B, we have 8x squared plus 12x. Okay, first I need to find what the GCF is. Once I know that, I'm going to use it to write the factorization as a product of GCF and something else. Okay? All right, let's do that. Okay, so let's first find what the GCF is. So the GCF of the polynomial. First, let's look at the two numbers. So there is a 8 and there is a 12. Look for what is common divisors, meaning divide both numbers. And whatever is the largest number, that is part of the GCF. So obviously 8 and 12 can be divided by 1. 8 and 12 can be divided by 2. So can be divided by 1, by 2. 8 and 12 can be divided by 4. I guess that's it. I cannot divide by 6. I cannot divide it by 8. I cannot divide by 12. Not both of them at the same time. So I have 1, 2, and 4. So the largest one, 4, is part of my GCF. Now, for the variable x, which is everywhere in this polynomial, all the terms, both terms, have an x. So definitely has to be part of my GCF. But the one I choose is the one with the lowest exponent, and the lowest exponent is the one with exponent 1. Okay? So the GCF for this polynomial is 4x. So my polynomial, 8x squared plus 12x, has to be written as 4x times something with two terms because I have two terms polynomial. So if this guy has two terms, when I factor out the GCF, which is always one term, the parentheses part has to also have two terms. Okay? Otherwise, it's not going to be the same polynomial. If it's not two terms, it's not going to be the same polynomial. All right. So now, how do I figure out what goes inside that parenthesis? Remember, I look for really the division of my GCF, which is 4x. So I take that and divide 8x squared. So 8x squared divided by 4x, and let me write this down with a different color. So my 8x squared divided by 4x is equals, remember, 8 divided by 4 is 2, x squared minus x to the first power, give me x to the first. So the result is just 2x. Now for 12x, so I have 12x, and if I divide by the GCF, which is 4x, well, x is going to be canceled. 12 divided by 4 is 3. So I use that 2x and the 3 to actually write what's inside my parentheses. So the GCF of 4x times 2x plus 3. And again, you can check to see that this is right just by doing that multiplication. So if the multiplication is the same as my 8x squared plus 12x, then it's correct. It's a factorization. And the GCF is like taking the largest chunk from the polynomial. And then once you divide by that chunk, the leftover goes inside that parenthesis.